Welcome to Testing Software and Systems at Amazon. My name is Charlie Roberts. I'm a senior SDET. I've been with Amazon about 6.5 years now, and I've worked in a variety of different organizations across all of it. I'm with AWS training and certification now. I wanted to walk you through a couple different areas that help me think about how to test software and systems at Amazon. So these are things that I've learned from my experience here at Amazon over the last few years, working in various different areas with various different products. So we're going to start off and talk a little bit about what's different about Amazon, some things that I think were really interesting to me and changed the way that I think about testing based on some peculiarities of Amazon. We're going to talk a little bit about it still being day one, which is a very Amazonian thing to talk about. We're going to discuss some of the underlying economics that drive some decision making and some questions I like to ask around automation and risk. And then we're going to talk about asking the right questions when you're trying to test software. I think this really underpins a lot of the efforts and work I do with different teams. And then we're going to finish up by discussing one of the tools that I've used at my org and others to help bring a lot of this together and drive higher quality in our products over the long term. All right, so what's different about Amazon? What makes Amazon different or interesting to me? I started working in the industry at a variety of startups and smaller companies. When I came to Amazon, it was really interesting to see how a large company could still, in a lot of ways, act small. There's a couple things that we do at Amazon that were very different and very new to me, and they changed the way I think about testing. So I want to kind of go through and share those with you to set a little bit of a framework. One of them is scale. At Amazon, we operate at a tremendous scale, one I had never seen before at any other companies I worked with. We have millions of customers for our products scattered all around the world. This, I think, really changes the way that you think about testing your software and think about quality. Something that might be a 1 in a million occurrence actually happens pretty frequently across our servers and systems. So that was really interesting to me. We're going to touch on that again in the future. Product longevity. This was really new to me too. Some of the products I've worked on have been around for 10 or 15 years. New products we're building may be around for that timeline or even longer into the future. So when you're working on a product you know that may last that long, it really changes the way that you think about building quality into the foundation of the product, building testing into the entire development process, because you know the work you put in now is going to have a very long time to pay off. And so that often influences the economics and how you think about testing too. Innovation. This is a really big one at Amazon. We're always pushing to release new, interesting products to delight our customers, right? This is something we spend a lot of time and a lot of effort on. And that means as someone who's in the testing space, you really need to be able to understand and learn new products, new technologies, and be able to take the same way you ask questions and try to understand the quality of existing products and apply that to new things that you may not have seen before. I think a really great example here is the Echo devices and Alexa, right? Trying to test something like that, very different from other experiences, maybe for just testing a device, Fire TV, etc. Ownership is a really big thing at Amazon. It's one of our leadership principles is all about ownership. And I think we see this as I've worked with different teams across and different organizations across Amazon and AWS. I see different people who are making judgments and decisions, given the information around them, the market conditions, the technology, etc., to make the right call for their space. And what one set of people do in order to test a product or a new feature may be different from what a different set does. And I think that that's okay. It actually, I think, is a really great example of how our diversity in the workforce and diversity in the way that we think about and approach technical challenges really pays off for us in the long run. Okay, it's still day one. You may have heard this phrase before. And Jeff Bezos' yearly letter to shareholders, he usually ends it with, "It's still day one." This is a very deeply Amazonian concept. The idea is no matter where we are, we're always starting, we're always looking fresh, we're always bringing everything we have. So I really think about this in the testing space when I'm working with teams or coming in and working with a product that may be at different areas of the software development lifecycle. I'm going to go through a couple examples here. I think we've probably all talked about and thought about quality in the design phase for a new product. We really want to get in there and understand, is this solving the right problems for our customers? Are we able to test this? Are we able to generate the data we need in order to test it, maybe synthetically or otherwise? How are we going to ensure that we're building quality into the product through CICD, et cetera? Another place that you want to bring fresh eyes is you've got a legacy product or something that's been there for a while, and you're doing feature releases. You're presenting something new, something interesting, something delightful to the customers. This may change the way the customers interact with the product. It may be a new technological innovation that means that the way you need to think about testing it has shifted. There's a lot of opportunity to think fresh thoughts and ask good questions, even when you've got something as simple as just a new feature release. Operating and scaling a product. This is a very large challenge, and it's something where testing, I think, is really core to being able to have a sustainable operational load and ensure that you actually can scale your product to meet the growth and the needs of your customers. So the challenges that you're facing when you're trying to scale a product and operate it are often quite different from what you see when you're just starting in the design phase or you're releasing a new feature. So this is another opportunity to really think fresh and get in there and approach ways to improve testing and quality. And deprecating a legacy system. This is something that I sometimes see people not paying a lot of attention to, but I think it's really critical, and it's been critical to me in my experience at Amazon. When you have a large system that millions of customers depend on and you're deprecating it and move to something else, you still need to make sure that those customers are taken care of and that that transition is successful and stable. And this is actually can be very challenging, but very interesting from a testing space too. So when you're thinking about testing, when I think about testing, I think about asking the right questions, because to me, it's always day one, and I'm always willing to come in wherever a product is in the software development lifecycle and start to ask and think about how we can improve the testing to ensure that we're getting the quality we need with the inputs and resources we have. So talking about asking the right questions, one of the things I like to think about is, do we have the right resources or enough resources to get where we want to go with this product? And that's usually one of the first questions you come to. And this to me boils down to economics, right? We're talking about the economics of automation. We're talking about the economics of risk. We're talking about the economics of quality. And when I think about economics of quality in a very large scale, I'm trying to think about, how do I take things that are scarce and how do I replace them with things that are maybe less scarce, right? And I'll get into some details here in just a second. But when I'm thinking about testing and when I'm asking questions about the product and where it is in the software development lifecycle, I'm really trying to understand how to take my existing resources and spread them out and ask the right questions to cover what we need to cover to reduce the amount of risk that we have when we ship this out to our customers, right? So you may wonder, what do you mean by scarce resources? Well, here's a couple examples. Here's a beautiful picture of a boat sailing across, I think, the San Juan Islands in northern Washington State. I would love to own that boat. I would love to be on it sailing right now, but I can't because money is a scarce resource, right? We're all pretty familiar with that in our personal lives, but it's there in our professional lives as well. Time. I think if we look at what's happening with trying to ship products to customers and delight them and get new innovative features and products out quickly, time is always of the essence. Being able to move into a market quickly with a new product is really valuable. So time is something that is very scarce. It's challenging to get more of that if you need it. Humans. And by this, I mean the people that you're working with, right? Our coworkers, our experts, people who are building the product or managing the product, products rollout, et cetera. They have deep expertise and knowledge about what's happening with the product, the market segment, our customers, what a quality product looks like and means. It's challenging to replace that knowledge. So these humans are a very scarce resource. And when you're thinking about appropriately testing your products, you really want to think about, how do I take the humans around me, my coworkers, et cetera, and how do I ensure that we're getting the most value from their limited amount of time, right, that they can contribute in the long run. Customer trust, very scarce resource. This is something, when you lose it, that is really, really, really challenging to get back. So in all the ways that we're thinking about and strategizing for testing our product or testing our systems, we want to keep that idea of we must maintain the customer's trust front and foremost, right? So it doesn't necessarily pay in the long term to take shortcuts if you end up impacting and losing your customers' trust. So that's the long-term goal we always want to keep. That's an extremely scarce resource. All right, so we've had some of these scarce resources, things that can be a challenge to replace or get more of. Now we want to talk about ways that I like to try and replace these or use other less scarce resources to make them more effective or efficient, right? So over the last, at least my time in the software industry, the cost of things like compute, networking, and storage have dropped dramatically. So anywhere that I can use EC2, Lambda, S3 for storage, other items like this, in order to take away a burden or make it easier or faster for some of our scarce resources like humans to be able to get the data that they need about the product quality, that I want to use that anywhere that I can. So if we think about the economics here, we have some scarce resources, we have some less scarce resources we can use in a smart way to try and replace or support those scarce resources. And if you kind of sit back and think about it, I think you'll come up with some testing goals that are similar to these that I often use, right? So I'm going to walk through these for you. The first is fast feedback. Now, as a developer, when I'm making changes to my product or a dependency is making changes that I rely on for my product to work, I want to know very quickly if there's going to be a problem or if my product is meeting the quality expectations that I have of it. So I really need fast feedback. I need to be able to hit the compile button and then get information back very quickly about not only did my unit tests fail, but were there reasonable or were there any integration issues with a dependency or maybe any performance issues that crept in when I put this new code in there. So fast feedback is critical. Automatic running of all of our test framework tools, etc., is critical as well. Why have it be someone's job to go and click a button to run the tests if you can make that automatic? Or even better, you can make it automatic as soon as someone is done compiling or cuts a CR or a pull request. Go and run those tests, get the information that you need to provide understanding for the developer about the quality of the product. I also need all my tests to be repeatable. So if I take the same product, the same version, I run a certain set of tests on it, and I run it today, and I run it tomorrow, and I run it the next day, if nothing's changing, I should get the same results. This is really important because when there's a test failure, I want to be spending time figuring out what the problem is with my product and not spending a lot of time figuring out what the problem is with my test framework or tooling, etc., right? So they need to be repeatable. I really want the cost of running all my tests to essentially approach zero. I want to make it absolutely free in my developers' minds for them to be able to run tests. This encourages them to run tests quickly, run them frequently, and get more information about the quality of their product. Now, it's great to run lots of tests. It's great if running them is essentially free, but it's not so great if finding out the root cause of a test failure ends up taking you 20 minutes or 3 hours, log diving, or other kind of issues like that. So when we write our tests, when we ask questions about our testing strategy, we want to make sure that the results of the test, when there's a failure or some other indication, allow us to easily identify the root cause, allow us to easily get in there and figure out what is exactly the problem. Because without that, fast tests may just start inundating you with lots of data that is very difficult to unravel because it's taking a long time to go through and figure out what the root cause or the original issue was. And then finally, we want our tests to be customer focused. We want our entire testing strategy to be customer focused. I want to test things that are important to my customers, that matter to them, that they're going to notice, that they're going to care about, right? So when we talk about performance, I'm going to talk a lot about perceived performance and ask, how are customers perceiving the performance of this application? Do they feel like it's fast or not fast? Do they feel like there's a problem in a workflow here, etc.? When we have a failure or an issue with a dependency, does our system degrade gracefully such that the customer experience can still be as good as possible given that situation? Okay, so we've got the overview, we've got economics, we've got some testing goals that come out of that. I want to walk you through some of the questions that I ask in different parts of the software development lifecycle when I go and work with a team or an organization on their product. Like I said, asking the right questions, I think, is a lot of what your test strategy should be about. So I'm going to give you some examples. We'll start off talking about the developer environment. So we've got a picture here of a young lady working on her laptop. Now, she could be just doing work right on the laptop, or could be SSH'd into a set of servers, or a large group of servers that she's running and managing as part of the dev environment. I love that we can now extend the idea of the dev environment beyond just the physical box the developer is working on. And I really try and take advantage of that whenever possible. It goes back to trading off less scarce resources for less scarce ones. One of the first things I like to ask when I go and talk to a group and we're discussing development environment is, I want to ask, are the unit tests that you're running actually effective? Right? And I don't necessarily mean here just, do you have high unit test coverage or code coverage or branch coverage, right? Because coverage tells you what you're testing, and I think really more importantly, it tells you what you're not testing, and that's a great area to look at and ask, should we be testing that? But it doesn't always tell you if the tests you've written that touch a line or touch a code branch actually are doing you a lot of good. So one tool I like to use here is mutation testing. There's a couple tools that are up on the screen that you can use. I've used some internal products for it as well. And the idea of mutation testing is you go into the code and you start mutating it, right? You start fiddling around with it, changing an equals to a not equals, other examples like that. And then you run your unit tests again. And you can imagine if someone came into your code base and started changing things in it, and you run your unit test and none of the unit tests fail, well, maybe those unit tests aren't all that effective. So the mutation tests help you understand, when my code changes, do my unit tests catch those changes? Do they indicate that there's a problem? So this is a very powerful tool. You don't have to run it every single day, every single commit, but it gives you a good idea of, are the unit tests you as a developer or your team are building, are they effective? Another thing to think about, on the developer environment, you want to really make sure that the local data you're dealing with here is representative. And by representative, I mean it has the same shape, it's the same size, it's using new features if they're out. An example of shape might be, if you have a product that's launching soon, you have no one registered to it, you would expect that at the beginning of the product lifecycle, you're going to have a very large number of registrations. And so you might have test data locally that represents, this is what our product is going to look like, the first day in, or something early where there's a lot of registration activity and data there. Whereas if you have a legacy product that's been around for a long time and registrations are a small percentage of the total traffic, you want your data set that you use locally to have that be a much smaller percentage, right? You want to have high fidelity to the data set and shape you're seeing in production. Same thing for size. In the software world, we often run into issues when things get bigger, bigger, and bigger, right? This is why scaling can be such an interesting challenge. So if you have a very large data set in production, but your data set for your development environment is very small or very trivial, this can lead you to potentially having a false sense of security. So I want to have a similar size. And another situation that I like to ask is, all right, have you launched any new features lately? Are your test sets, data sets you're using in your development environment, reflecting those? You might see an example where a team has a system where people are using Kindles or Fire TVs and interacting with it, and their test data might be representative of the most popular devices from 3 or 4 years ago when they created the test data, but there's new devices out now and those aren't reflected in the test data. We want to make sure that those are reflected so that you have high fidelity, good understanding of risk. All right, another thing to think about that I think is really important in your development environment is performance testing, and understanding perceived performance from the customer's perspective. Performance issues can be really challenging to track down and debug, so I love getting that information to developers very quickly. If you're adding a new feature or making a change, do you understand how that impacted the performance of the product? So being able to do performance testing at the developer environment stage is really valuable. You can start off with something as simple as just using your eyes, right? You as a customer, you using the product, does it seem fast to you? Is it reflective of what your latency and other numbers are telling you? And then I really want to get beyond just server-side latency. I want to think about interactions with the product. Whether you're scrolling, is there good fluidity? Are there workflows that could be shortened up that don't require necessarily as much interaction? These are all ways to think about performance in a customer-focused way. One tool you might use, and I've used in the past, is to actually take a video of the product as you're interacting with it. And then I built a tool that would take that video and split it into pieces and find phase transitions, right? So I've starting the product, I've got a logo up there, I've transitioned to a home screen, I've transitioned to a search result, etc. This is a way to help understand how quickly the customers can move through those different parts of the product and get you real feedback, what a customer sees, very quickly. All right, we're going to shift into continuous integration and deployment. And most folks at Amazon use CICD systems. We have a large internal tool that we use for this frequently. But I'd love to ask more than just, are you using CICD? But really dig in a little bit and ask, how are you using CICD? What value is it trying to provide for you? And is it lined up to do that for you? So one thing I look at is, are you doing stability tests first? Are you testing early in the continuous integration or continuous deployment pipeline to find out if there's a large product with the issue with the product that basically would fail most of your tests going forward? So make sure we understand, is everything pretty much okay before we start moving down the pipeline? We want to add stages as the complexity of the product and the testing space grows. So at Amazon, people often start with a beta stage, a gamma stage, and a production stage. And sometimes they never go beyond that. So you'll end up with a product that serves millions of customers that has, in the beta stage, hundreds of tests. Same thing for gamma, same thing for production, which is fine, it works. But I'd like to encourage folks to add an alpha stage or other stages in there so they can start to pull this testing apart and make it more time and computationally efficient. So we can move things earlier in the testing lifecycle that are quick, that gives us increase our understanding of confidence, and move things that are slower, take longer to run, or maybe take more data or more complexity towards the end, right? So this allows us at every stage, every step we're moving through the CI/CD process to increase the confidence we have in the product and reduce the amount of risk. Another thing to think about with CI/CD is, how long does it take you to actually find the root cause of a failure? I've worked with teams in the past that had extensive testing in their CI/CD pipelines. However, when there was an issue, it took them a long time to figure out what was causing the problem, whether it was actually the product or something with the testing framework, etc. So I think it's really important to make sure that you're testing a small number of commits so your problem space is small. If you can set your system up to test when one of your dependencies change, that's really critical too. You can get fast feedback. And running fewer workflow tests and more tests that fail quickly, I think, is another good option here. You've got two sheep here. These are clones. I think this is a great way to talk about your different stages in your CI/CD pipeline and whether they're cloning or modeling your production system with high fidelity. So as you get closer to production, the fidelity of that system that you're testing in, you want it to be closer and closer to what production looks like. This could be adding in production dependencies, making sure that the data size and shape in that stage is very representative of production. And this one's really important, making sure that the configuration you're using in these stages is identical as well. Differing configuration between non-production and production stages can lead to issues quite frequently. So making sure those are the same, really critical. There's various tooling you can use for this, for CI/CD. I've used internal tools at Amazon, I've used Jenkins, other things like that. AWS Code Pipeline is another good option for you. All right, so we've talked about the developer environment, we've talked about CI/CD. Now we're going to talk about testing in production. What questions should I ask when I'm testing in production? I think a really critical one is, can I find a system failure faster than my customers can? So if my customers are using a system in production, I want to know, hopefully before they do, if there's a problem. So one of the things we like to do is continuously model our customer interactions with our systems. So we have a product that can reach out and pretend you're a customer logging in, or pretend that you're a customer loading a homepage, or pretend that you're a customer who's searching for or purchasing a product, other things of that nature. And these run continuously and frequently. So if one or many of these start to fail, we're notified, our development teams are notified through alarms and indications that, hey, there's a problem. We didn't have to wait for a customer to see there was an issue, call customer service, have customer service got back to us. We were ahead of the game there. We were being proactive. Another thing to ask is, will my system scale successfully? Not just can it handle the scale I'm at today, or maybe 6 months from now, but thinking about product longevity, can it handle the scale I expect to see in a year or 3 years down the road, or maybe 5? So one of the important things to think about here is scale testing in production is really critical, because production is reality. Production, if you feel like you have a very robust, scalable system in a pre-production environment, you want to validate that in production because things can be different there between dependencies, the way customers behave, other issues of that nature. So do your scale testing in production when possible. This also allows you to choose the time when you're going to put your system at risk potentially. So if you're going to do a scale test or scaling experiment where you may put your system under a certain amount of pressure, you get to choose that time as opposed to having that time be chosen by you or for you by your customers at some point in the future. You want to understand if your system is resilient to unexpected events. And we often see systems that are doing great or doing great or doing great or under some pressure, brown out or have issues, and then take a long time to recover even after that initial traffic spike is gone. So we don't want to see that. We want to have systems that are resilient. We've got this picture here of the wine glass with the wine being swirled around it. This is kind of a resilient system. The wine is being perturbed, but none spills or sloshes out because the system keeps it kind of all contained, even though there's some perturbance there. So how can you do this? Well, you want to know what's likely to fail, not just your system, but around it as well. You want to model those failures. So if we depend on some kind of dependency downstream from us, we want to try and model and say, what happens if that dependency has 5% availability issue or has a latency spike? What happens to our system? Can we replicate that on our system? And can we validate that what we think will happen actually will happen? All right, so we've talked about a couple different areas where I like to ask different questions to understand the testing strategy. I'm going to now jump in real quickly and talk about scaling experiments, which are a tool that I've used with teams to help them bring these all together and ask questions about their system. So some different questions that you can ask through a scaling experiment are, how will my system behave for a certain event or a certain new release maybe? How is my mental model about how my system works the same or different from the people around me who also built and operate the system? Are my operational tooling like runbooks, dashboards, and alarms, are they actually effective? And what happens if I get that alarm at 3 a.m. and I'm woken up by my pager and I need to go and deal with a major issue with my system? Are we prepared to do that? What does that look like for us? Okay, so scaling experiments start with modeling your customers. You want to understand how they're interacting with your system. This is especially true if you've released new features or there's going to be some large marketing event or something like Cyber Monday, other issues like that, or Prime Day. You want to understand how they're engaging with it. So are they doing a lot of purchasing, a lot of searching, a lot of learning, whatever the case may be? What does that behavior look like? And you want to understand how that volume changes over time and how the engagement model changes with the volume. On a particular day, if you've got a new marketing release, customers may be doing a lot of searching or looking for a particular product, when on your average day, maybe they're not. These are all different events you can model with a scaling experiment. So you've got your model, you have a way to impart this model on your system through a load generation tool or something of that nature. You want to create some hypotheses around these. You want these to understand what's going to happen to your system. You want the hypotheses to be specific. So we may run into throttling issue with our Dynamo database. You want them to be verifiable, so things you can actually see if they happen or not. And it's totally okay to be wrong on these. I think you'll really find that when you get your group together and you start coming up with hypotheses, what will happen to our system on Prime Day? You're going to end up with different developers coming up with different ideas. And it's really interesting to ask them why. Now, I said it's okay to be wrong with your hypotheses, and I think that's totally true. So we've been running these in my org for over a year now, and I went back and I put together how many of these how many hypotheses we had been wrong. And I want you to just think about it. How many do you think we were wrong at? And then what do you think a good number to be wrong would be? But I'll tell you how often we were wrong. We were wrong 40% of the time. And actually, I think that's fantastic because that means 40% of the time we learned something that we didn't know about our system or a product before. And that's extremely valuable. So how do you run one of these experiments? You can get everyone together as a team, all virtually these days. You can use your operational tooling as you're running the experiment and impacting the system. Use your dashboards, use your runbooks. Make sure that you understand whether you have the metrics and data you need. And if you don't, now you have an action item to go get them. And I want you to run these frequently because your product is changing. You have new features. Your customers are changing. The marketplace is changing. Your dependencies are changing. And so understanding how your system scales or reacts to different pressures is going to be important because that entire organism is changing over time. So you want to make sure that you're running these frequently to refresh your mental model and have a good understanding of risk. All right. Thank you so much for spending time with me today. I want to make sure that when you're thinking about testing software and systems, that you're understanding and thinking about what are the right questions that you're trying to answer. This is an approach that I've used since I've been at Amazon, found it to be really valuable. Hope it's valuable for you too. Thank you very much. I'm Charlie Roberts.